I'm here with an affordability message. We're going to talk about 6 ways that you can reduce your energy costs in your facility. I have them in 6 categories: unnecessary running or idling, leaks, friction loss, some optimized efficiency, malfunctions, and system imbalance. Let's get right into it. First, let's talk about unnecessary running or idling. The picture that you see with the hallway, there is some pretty clear unnecessary running here. You see the light, it's lighting up the pipes at the top, and also there's nobody in this hallway, and yet all of the lights are on. This seems unnecessary. We can reduce that by putting in controls, by making sure our lights are pointing in the right direction. You can probably reduce by quite a bit by just looking for unnecessary running and idling. The other picture here is of an impeller that was running 24 hours a day, 7 days a week. And it's, as we who understand chiller impellers know, that it's not the runtime that's the problem here. It's that when the system is at low load, low flow, that it becomes kind of an imbalanced system, and there's imbalanced load that can cause damage like this. And when this failed, there was quite a bit of damage, and all that metal that you see missing from that impeller, it went into the system and really caused a lot of problems. So not only were they wasting energy through unnecessarily running this equipment when the load was very low, they also caused a huge maintenance headache later on when it failed because of that imbalance. So when you go through your site, take a look for some unnecessary running or idling. Number 2, leaks. So these pictures here are very obvious pictures of leaks. We've got lots of water. If you're walking through your site and you see water pouring out like this, good evidence that you've got a leak. But water leaks are only one type of leak that shows that you're wasting not just water but energy. So other leaks, if you're walking through and you hear a lot of hissing in your facility, that could be evidence of compressed air leaks or perhaps steam leaks. These leaks are also very costly. You're spending a lot of energy creating compressed air, and then you just leak it to the atmosphere. That's driving up your energy costs. Other leaks are heat leaks. For instance, if you look at a picture of your building, an infrared picture of your building, and you can see where you are losing conditioned air out of perhaps windows and doorways, that's another form of leaks. If you have uninsulated pipes with hot water or steam, that's also another form of leak, a heat leak, which you cannot see, but you can if you use infrared cameras. So take a look, walk through your site, look for anything leaking that's leaking not only water or steam, but it's also leaking energy and money. Number 3, friction loss. Friction loss comes in a lot of different ways. The most obvious might be the dirty filters that you see here, or the dirty intake over here. That is reducing the amount of air that can flow through that equipment, and it's really upping your fan power and increasing your energy use. But another example is this broken damper, where the fan is pushing against that damper, or trying to pull through that partially closed damper that is not able to actuate. That is really costing a lot of money in fan power, and you're not getting the benefit of it. Another good example of friction loss is this pipe that you see with lots of elbows in it. Anytime you're moving water or steam or whatever it is through that pipe, and you change the direction, you're introducing friction into that system, and you're losing flow, and you're losing energy in the process. Number 4, sub-optimize efficiency. I'm going to let you in on a little secret. Design engineers love their safety factors. Most systems are designed at the very top of the flow. So if for instance, we have all these pumps here, there's 4 pumps. That system was probably designed for a lot of pumping. But they don't need that. They have throttled almost all of them down pretty substantially if you look at those throttles. What that means is likely you could get away with 1 or maybe 2 pumps, and you could shut the other 2 off. That would be a much more efficient way of operating this system. So the design was for a much bigger need than they have at the time. Another example of suboptimized efficiency is this temporary chiller. Temporary equipment should be temporary. In this case, they had this temporary chiller in for much longer than they should have. And it's chilled water going through pipes that aren't very well insulated out in the outside and on the hot pavement, and you're losing a lot of efficiency by using that temporary equipment. So make sure that your systems are optimized efficiently, and you could reduce energy waste by a substantial amount. Number 5, it may be number 5 on my list, but it could be number 1 at your facility, is malfunctions. When I'm walking through facilities, I see this all the time, especially in facilities that have harsh environments. Take a look at these pressure gauges and think to yourself, what is wrong with this picture? Okay, I'll tell you. They're not hooked up to anything, and they're reading pressure in that doesn't exist. So the pressure should be at 0 in this case. Clearly, it is not. So these pressure gauges aren't working. The signal that they're giving is not going to give the right information to you, and your system will not be operating correctly. Also, the linkage for the economizer here, there is no linkage, right? If the software gives a signal to the economizer to open, no way that's going to open, not without the mechanical linkage. So malfunctions can be a big waste of energy. You can think, if you don't know, you can think things are operating, you can think all the signals are coming in and your system is operating correctly. But with a malfunction, you just never know, and you're not getting the right efficiency. All right, last but not least, system imbalance. 3 of these pictures here are VFDs. VFDs are great to get your system in balance, not imbalance. But if you want a system in balance, you want to put a VFD in and make sure you can turn down the speed of the input so that you can really optimize your system for the load that you need. However, many times when I walk through facilities and I see VFDs operating at 60 hertz at 100% or off completely, we see that is a big waste of energy. So not only is the VFD not turning down and you're not getting the energy savings from operating at a lower speed, you're also wasting energy by running the VFD. So if you walk through and you take an inventory of every VFD, see what speed it's at. If you see one that's either on manual at 100% or at 60 hertz, either turn it down, figure out how it can be turned down, or rip that VFD right out because it's actually penalizing you. Another good example is on HVAC systems. We see all the time simultaneous heating and cooling. That's a very big imbalance where your system is both heating up air and cooling down air and putting that into the space in order to get the right temperature. There's a lot of possible imbalance in HVAC systems. Taking a holistic view of your HVAC system is really key, and making sure your set points are right. Those are the 6 energy wastes. And you can click that QR code and check out our website. Thanks.